Let's explore linear bounded automata. These are space-bounded Turing machines and are used for context-sensitive language recognition. In this presentation, we will cover space-bounded computation and context-sensitive languages. So, what exactly is a linear bounded automaton? It is essentially a restricted form of a Turing machine. The key restriction is that the tape head cannot move beyond the portion of the tape that contains the original input string, meaning it can only use the space occupied by the input. Therefore, its space is bounded linearly. It only uses linear space relative to the input size and recognizes context-sensitive languages. The formal definition of a linear bounded automaton, denoted as capital M, is defined as a 7-tuple, capital Q, sigma, capital gamma, delta, small q, subscript 0 small q, subscript a, and small q subscript r. Capital Q represents the finite set of states. Sigma represents the input alphabet. Capital Gamma represents the tape alphabet, where sigma is a subset of capital Gamma. And delta represents the transition function. Let's discuss the key restrictions of linear bounded automata. Firstly, it is space-bound. The LBA cannot use more tape cells than the length of the input. Secondly, it has no extension. The tape head cannot move beyond the input boundaries, ensuring that it operates within the initially allocated space. Context-sensitive languages are recognized by context-sensitive grammars, where productions follow the form alpha, capital A, beta produces alpha, gamma, beta. This means A can be replaced by gamma only in the context of alpha and beta. Linear bounded automata exactly recognize context-sensitive languages. Let us consider the classic linear bounded automata language L, which is defined as the set of strings consisting of A to the power of n, B to the power of n, and Z to the power of n, where n is greater than or equal to 1. This means the language consists of strings with an equal number of A's, B's, and C's appearing in that sequence. Examples of valid strings include ABC, AABBCC, AAABBBCCC, and so on. Consider an algorithm for a linear bounded automaton to recognize the language A to the power n, B to the power n, C to the power n. While unmarked symbols exist, mark the first A, find and mark the first B, and find and mark the first C. After the loop, if all symbols are marked, then accept. Otherwise, reject. The algorithm uses tape space efficiently by marking symbols in place, ensuring it stays within the linear bound. Now, let us explore the key properties of linear bounded automata. Firstly, they are decidable. The membership problem, determining if a string belongs to the language, is decidable for linear bounded automata languages. Secondly, context-sensitive languages are closed under union, intersection, and concatenation. Thirdly, when considering the language hierarchy, context-free languages are a subset of context-sensitive languages, which in turn are a subset of recursive languages. And finally, context-sensitive languages are not closed under complement. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.